Hey folks, in this video we're going to be talking about the mole and Math Jones. Wow! Let's get started. So, the mole is this central unit that we use to convert between other units. I should finish this up with other sides to these arrows because the mole can be used to convert back and forth between these different things. If you want to know how many particles you have, but you only know the mass of a substance, through the mole you can convert to particles. It will be a two-step conversion, but you can do it. If you have a gas and you happen to know its volume, and you want to know, I don't know, how many particles of gas you have, through the mole you can go to get to particles. Or maybe you want to know its mass and only happen to know its volume. You can figure that ish out. Now for each of these arrows we need conversion factors. For this top one, it's the top dog. I put it up top because it's the mole. When we talk about the mole, we should probably talk about Avogadro's number. Yeah, that's right, my dude Avogadro. Look how funny his face is. It's a funny face. Anyway, Avogadro's number is this buddy right here, who's a big old number who I don't feel like writing out, but there it is written out. That's a big number. Look how big it is. Anyway, I want to just grab it and put it down here for later. Anyway, so Avogadro's number we can use to convert because there are this many particles in 1 mole. That is the conversion factor that we can use to convert between particles and the mole. Well, great. What are these other particles? Other particles? Other conversion factors. Well, here we've got a conversion factor, and it is 22.4 liters equals 1 mole. Now, this conversion factor route only works when we are at STP, which we'll talk a little bit about that later. That's the worst looking @ sign you've ever seen. Anyway, over here is this one. This conversion factor is the spiciest puppy of them all because the conversion between mole and mass varies depending on what chemical we're talking about. So, for this, we're going to say the conversion factor is going to be the molar mass, which is a cool name because it's like the mass of a mole. I don't know why they didn't just call it the mole mass. Maybe somebody got confused, but this looks like we're talking about teeth, but we're not talking about my teeth. We're talking about molar mass, the conversion factor between mole and mass. And so usually this is going to be expressed in grams, and it's the number of grams equal to 1 mole. Jeezy peepers, where should we go from here? We should probably talk a little bit more about molar mass. Ooh, it's so enticing. So, as we're talking about molar mass, we should specify again that this is the mass of 1 mole of a specific element or compound. How do we come up with the molar mass? How can you possibly know that? Well, before we talk about that, let's leave a little bit of suspense in the air. I want you to know that molar mass, we're typically going to see it expressed either like saying something like 16 grams equal to 1 mole, or else you might see this expressed as a fraction, because fractions are litty city, and that would look like 16 grams over 1 mole. Typically, this is how we would see molar mass expressed. And how do we figure out if something's molar mass is 16 grams per mole? Well, the way we're going to do that is we're going to get the molar mass from the periodic table. Get from the periodic table. What? How could we do that? I know the periodic table is super useful in all sorts of situations, but how are we going to get that periodic table to help us with the molar mass? Well, the way we're going to do it, come on up, periodic table, is check it out over there. See? Right here. No, stop moving around. Stop. Right there is an element's symbol on the periodic table. And at the bottom of this guy right there is this number, this non-whole number. At the top we have our atomic number, but down here we have the atomic mass of a particular element. For that element, it is the molar mass. 1 mole of that element has that weight. Wow. Oh my gosh. That's so exciting. But get this, if we're talking about a compound, we have to look at the mass of each element in that compound add all those puppies up, and that's how we're gonna get the molar mass. Let's do a minutia of practice with that. Right about, I don't know, now. Look at that. We've got some more, what are words? We've got some chemical formulas for compounds, and we're gonna come up with the molar mass of them. If you have a periodic table at home, you should pull that puppy out, because I'm gonna ask you to try to do this on your own, and you're gonna want a little bit of a reference for that. Maybe I can just make it pop up on the screen. I probably can do that. So, CO2, how am I gonna figure out the molar mass of this guy? Well, as I alluded to earlier, I'm gonna look up the symbol for carbon, and I'm gonna see, oh, look at that, your mass, atomic mass, is, let's say 12. This one says 12. I'm just going to take 12. And so there's one carbon in here, so I'm going to add in 12 ones. And then I'm going to look up my atomic symbol for oxygen on my periodic table, and I can see that this dude's molar mass is like 15.99. Well, I'm going to round it up to 16 just to keep things simple right now. And so I'll say, all right, we've got oxygen in here too, 12 plus 16. But because there are 2 oxygens in this puppy, I should note that and multiply this dude by 2. That's 12 from that carbon, and 2 16s from the oxygen. And that's how I'm going to get the molar mass for this bad boy. When I add all that together, what? Your 32 plus 12, that comes out to 44. And as we said earlier, we're going to give this units that are grams divided by moles. This is a conversion factor. You could also think of this as being 44 grams equal to 1 mole. But typically you will see it expressed this way. So dear humans, I want you to be comfortable with seeing molar mass presented in that form. Well, why don't you, based off of that and having your own periodic table, why don't you give these two a try and then we'll go through them together? Sick. Try that out? Well, let's go through them together. We already know that carbon has a mass of 12 from doing this previous problem, and there are 3 of them, so I'm going to put a little 3 next to this to tell me, hey, multiply 3 by 12. You might be pissed off at me right now for not putting the 3 in front of the parentheses, because that's usually how we do stuff in math, but I'm putting it after because the subscript for carbon comes after, and I'm just trying to be kind of consistent here. I'm just trying. Anyway, so we move on to hydrogen, and there's, what's our atomic symbol for hydrogen? Oh, there it is, and we can see that dude has an atomic mass of 1, so much fun. So I'm going to take 1, and I'm going to multiply that by 6, because there are 6 hydrogens in this bad boy. And then lastly, I got to talk about nitrogen. Nitrogen, your symbol is about that, and I know that your mass is approximately 14. I'm going to round to that, and I'm going to multiply that by 3. And now I can do all this math. Well, this is 36 plus 6 is 42, plus this is another 42? That's so weird. 42 plus 42 equals 84 grams per mole. That's super weird. I just got to take a second, because that's freaking me out. All right, now I'm back. And so we can move on to this next one. Titanium has an atomic mass of 47.88. Sorry, I didn't pull up a brick for you. But there are how many of those? 2. And so we also have to include our oxygen in the mix. And there are 3 of those. So I can do this, and that's 48 plus, you're pretty close to 48. And 2 48s would give me 96. So this is going to be 95.88 grams per mole. And that's how we figure out the molar mass of a chemical. It's not too spicy, unless you don't have a periodic table. And then it's like, dude, how do you think you're going to do that? You need your periodic table, dude. You need it. Anyway, what should we talk about next? Let's just talk a little bit about how we would go through doing some sweet, tushy conversions with this here little roadmap of the mole as a tool.
It's time for science!
Okay, but seriously, it's time for science, and we've got a problem behind us on the board. Let's talk about it. How many moles are in a sample containing blah, blah, blah? You can read it. Why don't you, dear human, before we go hard on this and I help you out with it, why don't you try this out using this here cool diagram? Great, you done tried it out. Well, let's talk about it together as a squad, because we homies, dog. We homies. We're homies for life. For life! Anyway, so, how many moles, the sweater is coming off, are in a sample containing 20.5 grams of glucose? Well, if I want to know how many moles are in this sample, and I know the mass of that sample, then what I'm going to need to convert betwixt these two is the molar mass. Wow. I'm going to need to calculate the molar mass of this first. I will use that as my conversion factor, and that will allow me to convert between mass and moles. And if I want to go on to figure out how many molecules are particles, are in the sample, then I can convert from moles to particles, knowing that 1 mole is equivalent to Avogadro's number 6.022 times 10 to the 23rd particles. So, first thing up, we need to figure out what that molar mass is. Let's do that the way we practiced before. If you didn't know what to do, pause the video and do that now. Great, now that I got out of the way, you can get that done. Well, let's talk about it together. If we're talking about, let's actually do that up here because we got some room. If we're talking about C6H12O6, you may remember from before that carbon has an atomic mass of approximately 12. We're going to round and be some lazy kitties right now. But if we got 12 as the molar mass and there are 6 of those dudes, then I'll do 12 times 6. And I'll look at this hydrogen and I'll be like, hydrogen, well, you've got an atomic mass of approximately 1 gram per mole. And so, let's see, get out of here, flame. You're smoldering and making some flickery smoldering sounds. Anyway, there are 12 of these carbons in this bad mamma jamma, so I'm going to multiply that one by 12. And then, who else is in here? Oxygen, you clever little rascal. Oxygen, get out of my way, sweater. Well, oxygen has an atomic mass of approximately 16, and there are about 6 of those oxygens. There's not about 6, there's exactly 6. And so I'm going to multiply the 16 by 6. Well, let's see, that comes out to 72, plus another 12 is 84, plus, oh my gosh, what do you come out to? Off the top of my head, I'd have to say that would be 96. And 84 plus 96 is going to be equal to 180. If I did my maths right, we got a dude whose molar mass is 180 grams per schmole. All right, cool. That's going to be our conversion factor. So we can get started with this problem now. We can convert, and if you don't remember how to convert, I'm pretty sure the link should appear over here. I didn't screw it up this time, I hope. So yeah, check that out if you don't remember how to do basic conversions. But I'm going to take the number I want to convert. That's my 20.5 grams. All the other numbers are based off this. The sample contains 20.5 grams, and that will determine the number of moles and also the number of particles. So I'll do 20.5 grams, and then I'm going to want to convert this into, first of all, how many moles. I want to get to moles. Those are my desired end units. So we'll put an equal sign and leave some space to write a number. And to convert, I'm going to multiply this by my conversion factor in fraction mode. And my old units should get canceled out. So I want my grams down below, and I want my new units, my moles, up top. And if I look over at my sweet tishy molar mass, I see that it's 180 grams over mole. Or we can assume 1 mole. Well, I don't want it that way. I want to flip it. I want grams in the denominator because they're the units we're trying to cancel out. So I'll pop my 180 down there. I'll put a 1 up there, and I'm ready to do some math. Oh my God, let's make the math. There's an answer right there. Oh my goodness, it comes out to 0.114 moles. How exciting. We have answered the first part of this question. We should give ourselves a nice pat on the back. Let's get another one of those. And we could also brush our shoulders off while we add it. So, what's next? Well, we want to convert to molecules at this point. Why don't you, dear human, pause the video if you haven't already done this, and try doing that conversion yourself. Beautiful. You tried it out. Just beautiful. Well, let's do it together. We're going to take our answer from this, because we want to go from moles now to particles. And we're going to use that 6.022 times 10 to the 23rd particles being equal to 1 mole as our conversion factor. So, let's see. What do we want to do? We want to change our moles, which we have here, into particles. Beautiful, baby. So, I'll do moles, and I know I'm going to multiply that by conversion factor, and I want to end up with an equal sign, but that doesn't need to be over there. It needs to be like there. And that's going to give us some number of particles. Beautiful. Let's start filling in some numbers from our conversion factor. It's not written down, but again, 6.022 times 10 to the 23rd particles is equal to 1 mole, equals 1 mole. So, with that in mind, let's see. What are the new units we want? We want particles. We want to know how many molecules, that's the type of particle, are in the sample. So, I'll go ahead and write, molecules up top. Because when we talk about particles, it could be molecules or atoms or maybe formula units. But usually, we're going to specify atoms or molecules. Okay, great. And so I know I want to get molecules, and I want to get rid of these pesky moles. Maybe I should hire an exterminator. That wouldn't work. I'd need a chemist. And so let's go look at our conversion factor. Well, this is the number that goes with the particles, 6.022 times 10 to the 23rd. Beautiful. And what goes with moles? Oh, 1. There are that many particles or molecules in 1 mole. fancy pants at dad. Now all I got to do is my math. Let's see, can a magical math fairy help me out and like schwap? Ah, thank you. Oh, I erased it a little bit in my schwapping. Stupid hands. Well, it comes out to 6.86 times 10 to the 22nd particles. Gorgeous. I did my maths. How did I do that? Well, I multiplied the number I wanted to convert by the information in the numerator and then divided by what was in the denominator. So I just took this 0.114 and multiplied it by Avogadro's beautiful number, 6.022 times 10 to the 23rd. Let's look at Avogadro again. Oh my gosh, he's such a peculiar looking man. Anyway, let's look at like one or two more example problems. It's time for this problem. Check it out. Oh, wow. So, why don't you, dear human, pause the video and try out this puppy. Actually, before you do, you might be wondering, what is standard temperature and pressure? Well, when we're talking about gases, they behave differently depending on the pressure and the temperature. So it's helpful to standardize that stuff. So when you're doing experiments, you just bring your gases to this temperature and to this pressure, and you know the gas in your laboratory is going to behave the same as the gas in the laboratory over in Zurich, or wherever you're comparing stuff to. Great. Well, let's write down the values for that over there. Wow, there it is. Oh my gosh. So a standard temperature is a chilly 0 degrees Celsius, and a standard pressure is 1 atmosphere, which is about the amount of pressure experienced on Earth at sea level. Gorgeous. Well, now that we've got these beautiful dudes in place, let's look at how to solve this problem. I think I'm going to go over there for that. Great. So I got toasty doing that flying. So how are we going to do this? Well, maybe I need to go back over there. We're going to convert from volume, which we know, all the way over to mass, which we'd like to know, and we're going to take a pit stop at mole along the way. Beautiful. Well, I think for this we're going to need the molar mass of helium. Fortunately, that's nice and easy because helium is a single element, and we can look that bad boy up. Check it on your periodic table. Great. We found the same thing, that it has a mass of approximately 4 grams per mole. Cool. Well, dear human, now that we have that in place, and we have this conversion factor, why don't you try out this goober by yourself? I'm just going to go away. Fantastic. I'm glad you tried that one out. Well, what I'm going to do here is I'm going to start with my 800 liters. And I know if I'm starting at volume, my first step is going to be to convert to moles. And then my second step is going to be to get over to mass, because each arrow we cross is another conversion step. So I'll start with my 800 liters, and this is going to be my step 1 conversion. And I know I'm going from liters to moles. I'm going from the volume to moles as my first step. So the new units I desire are moles, and we'd like our liters to cancel out down here below. Cool, and I can plug in the values for my conversion factor. I know that 1 mole is equivalent to 22.4 liters, as long as we're at standard temperature and pressure and talking about gases. Cool beans. Well, let's just do this all consolidated style. I'll just pop in my next conversion factor for step 2. What am I doing in step 2? Well, I'm converting from moles over to mass. So let's see. Moles is the unit I'm going to get rid of. That's my old unit. And at the end of step 2, I would like to have mass units, which are typically measured in grams. So I'll pop some G for grams up there, because I'm an OG. No, I'm just a G for grams. Ha ha ha. Tracy Morgan is the original OG, I think. That's his show, right? I don't know. He's so old now. Anyway, let's look over at our conversion factor for molar mass. We know that there's 4 grams per mole. 4 grams for every 1 mole. So I'm going to pop a little 4 in there. I'm going to pop a little 1 in there. And now what I can do is take my number to be converted, my liters, and multiply it by 1, and then multiply it by 4, and then divide by 22.4, and divide again by 1. These 2 steps are kind of pointless, because multiplying and divide by 1 fat. So really, I'm just going to take this and multiply by 4 and then divide by 22.4, but it's good to talk about the whole thing. And what's going to happen when we do that? What's going to happen with the liters? They're going to get canceled out by these liters, because we're doing divided by here. And then we'll have moles, but these moles are going to get canceled out by these moles, because we're doing some division here. This divided by that. Ha, go away. And so we're left with just units of grams. And what does that come out to, dear humans? What does it come out to? It was on my calculator, and it's gone. All my dreams are dead. Back to life. the answer comes out to that, a fabulous, what is that, 142.85? Super cool. We know that this sample is going to have a mass of 142 let's round that up to 9 grams. Fantastic. What is it? 8 grams of helium. It's nice when we're doing mole problems to specify what chemical we're talking about. It's nice to do that. It's nice for your instructor. It's nice for you. It's nice for the world. All right, let's look at maybe like one more example of how we do this spiciness. So it's time for, oh my God, the stool. Ha, just fine. So it's time for this last year problem. Why don't you try doing this, dude, yourself? I'll get down a little bit so you can try it. Great, you tried it. Well, we're converting stuff, and it involves N2O, laughing gas. I hope you're feeling funny. And so we want to know what volume. So we definitely want to get over to this here volume guy. Nice purple. And what are we starting with? Well, we know it contains molecules. Molecules are little bits, aka particles. So we're starting up here, and we're going to go through the mole, because we always go through the mole. And we're going to get on over from particles to volume. Sick. Game plan in mind. Let's dooze it up in a fine, crisp, black marker. Love you. So we're going to start off with this number, this 4.5 times 10 to the 30th. That's a lot of molecules. And we're going to convert that into these there. What are we converting it into? Let's double check the plan. Oh, we're going from particles to the mole, because we always go to the mole. Great. And let's see. Our answer should be in moles. And we're going to need to put some stuff into our conversion factor. Let's get that in there like that. Well, that's great. We've got some units, but we would also like to have some stuff from our conversion factor. So could you please appear in there like that? Oh, thanks. Thanks for appearing, friends. Okay, cool. So now we can do this conversion. We've got our old units, molecules that we don't care about anymore, down below. And we've got our new units, that ones that we're going to get us on our way over to that volume in the numerator, because new stuff goes in the numerator unless you want to change the denominator of a number, and that's for another time. Check out this video if you're more curious about that. This one over there. Thanks. Okay, cool. Well, I can plug this into my calculator machine, and I'll get some kind of answer. Calculator. Wow. I've got a hat on now, and also we've got a big old number. That's a big honking number. 7,472,600. Jeez, I'm just going to round that to 7,472,000. 7,472,000 moles. That's quite a bit of moles. Well, now we can go ahead and convert those moles. What did we want? Oh, we wanted volume. What volume? We can convert that into volume using this cool kid, conversion factor. So let's go ahead and do that. We'll take our 7,472,000 moles, and we'll go ahead and convert that puppy into volume. Our typical volume units are going to be liters, and I have a feeling this is going to be a lot of liters, because if liters are our new unit, well, that should be up top in the numerator. And our old unit is moles. We're going to convert away from moles, because we're going to go from moles to liters in volume. So I'll put my moles down there, and I'll pop in my 22.4, because that's from the conversion factor. 22.4 liters equals 1 mole, and so I can I can math that puppy out. Let's do's it with the calculator device. Dude, that is such a big number. Dude, 167 million, we're just gonna round to that. 167 million liters of this laughing gas. That's a lot of laughing gas. That's a lot of laughing gas. That's tanks on 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 tanks of laughing gas. Cool. Well, that's our final answer. We should specify this a little bit nicer. That many liters of N2O. You know what else I could do? I could say of N2O. So much nicer. Anywho, that's the end of this here video. I hope you enjoyed this thing and learned some stuff from it. Ta-ta, and have a great... Wait. You should like this video. Smash it. Smash your computer. Smash your phone. Then go into the next room and, smash something else. Then subscribe. But you already destroyed your phone, so never mind. Ta-ta, have a great rest of your life.